Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve 60 in your upcoming KCET 2025 exam. And for that we are discussing each and every chapter, also previous year question paper of that chapter, and at Sunday we are coming up with KPL, KCET Premier League. This Sunday there will be KPL mock test number 7, that is match number 7, and there you will have questions from dual nature of radiation and matter chapter as well as atoms chapter. Okay, so next Sunday, okay, you will have questions from dual radiation and matter as well as atoms chapter. And why I am announcing that on Thursday, because there is a surprise waiting for you that I will not reveal right now, but for now you should know that this Sunday KPL number 7, match number 7, you have to play against dual nature of radiation and matter as well as atoms. Okay, and today I am going to discuss all the previous year questions from atoms PYQs. Now if you want to participate in KPL, and if you have not yet participated in any one single session of KPL, you can still do that by joining our WhatsApp group. The link is given in the description below. Okay, and it is absolutely free. There is no charge. You don't need to pay anything. Only thing that you have to do, you have to follow our WhatsApp channel. The link is given in the description. At Sunday at 10 a.m. we will share the question paper with you. You can download the question paper from our WhatsApp channel, and once you download the question paper, you can solve it throughout the day, and at night I will be back with the solution of the entire question paper. You can check the solution on Sunday itself, or you can check that on Monday afternoon, whenever you are free. But don't worry, if you are very serious about KCET 2025, do not miss KPL sessions. Okay, so I am seeing that people are seeing our lecture videos, seeing our PYQ videos, but not many are watching KPL because they are not even trying to attempt. It is absolutely free. You can download the question paper, try to solve it, and check the solutions once you are done with the questions. Right now, today we are going to discuss atoms PYQs, very important chapter. At least 2 to 3 questions sometimes comes from this chapter. Average 2 questions coming from this chapter every year, and pattern wise also one question is very common type of question, and one question is little bit difficult type of question. Okay, so let's see what all the questions coming in previous years. So in the Rutherford's alpha particle scattering experiment, as the impact parameter increases, the scattering angle of the alpha particle. So we know that what is impact parameter. Let us discuss that first. So we have gold nucleus here, a gold nucleus here, and one alpha particle moving towards the gold nucleus. Right now, the distance between this and this is called the impact parameter. We termed it as B. Right, increasing impact parameter means it is going far away. So now if we throw a alpha particle, so impact parameter is now very high. So what will happen in this case? In this case, this atom will not at all deflect. It will mostly going to go straight without interacting with the nucleus. Right, so what is happening to the angle of scattering? Angle of scattering, if it is straight, so if the impact parameter is 0, we discussed one question. So if the impact parameter is 0, then the atom will rebound, so it will be 180 degree. Okay, if the impact parameter is very small, then it will interact and it will reflect, it will deviate by a huge angle. But if you increase the impact parameter, the scattering angle will be very less, almost 0. So scattering angle definitely decreases. You have to be careful to answer such questions. So impact parameter increases, scattering angle should also increase. No, if impact parameter increases, scattering should be 0, so it will decrease. Right, now let's move on to the next question. This is a very interesting question. 3 energy levels of hydrogen atom and the corresponding wavelength of the emitted radiation due to different electron transitions are shown. Okay, then they have asked you to find the relationship. Now what we know, so let us first write what we know. We know that H new equals to E initial minus E final. If you remember, okay, initial should have higher energy, final should have lower energy, because electron always moves from higher energy to the lower energy. So in this case, suppose this corresponding frequency is nu 1, this corresponding frequency is nu 2, and this corresponding frequency is nu 3, suppose. Okay, also we know that nu equals to C by lambda, so we can write this as Hc by lambda. So let's not invest our time on frequency anymore. We can simply write them in terms of wavelength lambda, and we can write it as Ei minus Ef. Now can you write for lambda 1, lambda 2 and lambda 3? Let's see. So first start with lambda 1. Okay, for lambda 1, electron is jumping from E2 to E1. So electron is jumping from E2 to E1. So Hc by lambda 1 equals to E2 minus E1. Right? So simple as that. Now what is lambda 2? Lambda 2, electron is jumping from E3 to E1. So Hc by lambda 2 equals to E3 minus E1. Okay, and Hc by lambda 3 equals to lambda 3 is E3 to E2. So E3 minus E2. Right? Now what we will do, suppose this is equation 1, this is equation 2, and this is equation 3. Okay, now what we will do, if we add 1 and 3, you have to see it, you have to analyze the equation and then realize what all you can add. So in this case, if we add 1 and 3, you will see that this E2 will cancel. Okay, E2 is in between level, so you have to cancel that out. So let us add that Hc by lambda 1 plus Hc by lambda 3 equals to E3 minus E2 plus E2 minus E1. So E2 will cancel. So what will left? E3 minus E1. Now what is E3 minus E1? E3 minus E1 is Hc by lambda 2. Okay, this is that. So our physics is over here. Okay, now next is only mathematics. Some calculations, some approximations. What we will do? We will, first of all, we will cancel all the HCs. So what we will get? We will get 1 by lambda 3. So let me write this part first. 1 by lambda 3 equals to 1 by lambda 1. Sorry, this is not lambda 3. This is E3 minus E1, right? So E3 minus E1 means lambda 2. So it will be lambda 2. Right? E3 minus E1 is lambda 2. Right? So here we will write 1 by lambda 2 equals to 1 by lambda 1 plus 1 by lambda 3. Okay. Now this is basically the parallel combination of resistances. Okay. I can write this in a single line. Lambda 2 is equal to lambda 3 lambda 1 by lambda 3 plus lambda 1. If you remember the logic of parallel combination of resistances or series combination of capacitors, you can write this in one line, or you can simplify this and you can write this as usual. Okay, so no matter how you write, if you remember this, okay, this is basically parallel combination. So in parallel combination, we can simply write the term R equivalent is equal to R12 divided by R1 plus 2. So similarly, I have done that formula, and we can see that what is the correct option. Correct option is lambda 1 lambda 3 by lambda 1 plus lambda 3, that is equals to lambda 2. So correct option is option C. Choose the option correctly, not so difficult, right? In accordance with Bohr's model, the quantum number that characterizes the Earth's revolution around the Sun in an orbit of radius 1.5 times 10 to the power 11 meter with orbital speed 3 times 10 to the power of 4 meter per second is given mass of the Earth is 6 times 10 to the power 24. Very interesting question. We know that orbital angular momentum is given by, for a Bohr radius, nh by 2 pi. right? So nh by 2 pi is the Bohr's radius, Bohr's formula, Bohr's theory, that he said that orbital angular momentum should be integral multiple of nh by 2 pi. Here, what is angular momentum? If you remember in your PU1, okay, we will revise PU1 very soon. So angular momentum is given by r cross mv, right? Vectorially, scalar wise, if they are in the, we don't need to write cross product, okay, if theta is 90 degrees, so we can write mvr. In this case, theta is 90 degrees. We know that the earth is rotating almost in a circular orbit, so this is the direction of r, this is the direction of velocity, so the angle between them is 90 degrees, so it will be simply mvr, right? Now let us put the values of this in this equation. So mvr equals to nh by 2 pi, right? Now what they have asked us, they have asked us to find the quantum number, okay? Quantum number means n. We have to find n for this relation. So n is basically equals to mvr times 2 pi by h, right? So this is simple. So now we have to put the values. What is the mass of earth? Mass of earth is given 6 times 10 to the power of 24. 6 times 10 to the power of 24. And what is the velocity of the earth? Velocity of earth is also given. Everything is given in actual unit, okay? So it is kilograms. Speed of orbital speed of earth is given meter per second, so we don't need to change it, okay? 3 times 10 to the power of 4, okay? And what is the radius of earth? The radius of earth is also given 1.5 times 10 to the power of 11 meters, okay? Instead of giving in kilometers, they have given in meters, so which is fine, okay? And it is not radius of earth, it is the radius of the orbit of earth, okay? So this is the radius, okay? Earth is here. Now what is h? Also there is a 2 pi, 2 times 3.14, okay? And here will be 6.6 times 10 to the power of minus 34. Okay, now here first of all we will do some approximation as usual. Knowing the approximation, applying the approximation is very essential to clear KCET, because there will be no calculators available to you, so you will not be able to solve questions using calculators. So you have to practice solving questions without using calculators. So 6.6 and 2 times 3.14 we will cancel, okay? 2 times 3.14 is 6.28, right? So it is almost equals to 6.6, so we will almost cancel this term. So 2 pi and this 6.6 are cancelled, okay? Now what is left? Left is 6 times 3, that is 18. 18 times 1.5. So what is 18? What is 1.5? If you know, it is 3 by 2, right? So you can cancel them and you can write 9 by 9 to the 18, right? Now what is the 10 to the powers? All the 10 to the powers, 10 to the power 4, 10 to the power of 11, right? And 10 to the power of 24, they are all plus. 10 to the power minus 34, it was in the denominator, so once it goes up it will become positive, right? So what all the 10 to the powers, let me write it here. 24, then 4, then 11 and 34, okay? So they are all 10 to the powers, and once this goes up this will also become positive, so I have already written them. So 4 4 is 8, 9, 13, 3, okay? Then in hand 1, 3 plus 1, 4, 4 plus 3, 7, 73. So 27 times 10 to the power of 73. Now if you see, there is no 10 to the power of 73 in the option, only 74 in the option. So let me rewrite this as 10 to 2.7 times 10 to the power of 74. Okay, so 2.57, because we approximated, so our approximated value is very close to the actual answer, so correct answer is option C. So after doing approximation, don't expect the answer to be exactly matching to the given options, okay, but it will be very, very close. Like for example, it is 2.7, it is 2.57. What is the difference? 0.13 difference, right? So we can consider that much difference because we are not using calculators, we are not using any other things. Only what we are doing is we are approximating. A good approximation is very good, as good as a calculator. Okay, so for cracking the competitive exam, any competitive exam, if you are preparing for, you have to have the knowledge of approximation. Right, now next question. An electron is revolving in its Bohr orbit having Bohr radius of 0.529 angstrom. Then the radius of third orbit is. Now first of all, what is Bohr radius? Bohr orbit. Bohr orbit is nothing but when n equals to 1. Okay, when n equals to 1, that orbit is called Bohr orbit. Now we know that radius Rn is proportional to n square. Right, we have discussed it during our lecture that radius of electron in hydrogen atom is directly proportional to n square. Now, so R1 by R3, they have asked you to find the Bohr orbit in radius of third orbit, right? So R1 by R3 should be equals to 1 square by 3 square, right? We are trying to find R3. R1 is given. So R3 is equals to cross multiply, right? So 9 R1, this is 1, right? So just cross multiply and then you have to find the value. So 9 times 0.529. So what is the value? Assume this as 0.5. Assume this as 0.5. So 9 times 0.5 is 4.5. Okay, it will be slightly more than 4.5 angstrom. Unit is given in angstrom, right? So correct answer is 4.761 angstrom. Okay, 4.761 angstrom is the correct answer, as all the other options are not even close to this value. Okay, so this is how we do approximate and we calculate the correct answer. Now the radius, see another similar question. This was another year. I think that question was 2022. This is 2021. Almost similar question. The radius of hydrogen atom in the ground state is 0.53 angstrom. So basically same thing. R1 is given. R1 is given 0.53 angstrom. Okay. And after collision with an electron, it is found to have a radius of 2.12 angstrom. The principal quantum number n of the final state of the atom is. Now we know that R1 divided by R unknown. Okay, unknown I am marking it as R star. Okay, is equal to 1 square by n square. What we are trying to find? We are trying to find this value of n. Okay, R1 is given 0.53 and R star is given 2.12. Okay, and 1 square is 1, n square is n. Okay, now what is n square? N square is 2.12. Just flip both sides, 0.53. Okay, so 0.53. Now how can we solve it? It is very difficult to solve. So not so difficult. What we will do, first of all, we will remove the decimals. 212 divided by 53. Okay, 5 4s are 200, 20. 5 4s are 20. So 50 4s are 200. So it will be 4. Okay, 3 4s are 12, already matching, right? So it will be 12. You can do the division, or you can do this kind of approximation that, okay, 5 4s are 20. Okay, so 50 4s are 200. So this is the closest number. So n square is 4. So n equals to 2. So the value of n is 2. Okay, this is also similar question that we have solved. In this case, they have given you the value of radius and asked you to find the n. In the previous problem, n was given and they had asked you to find the value of r, right? Now energy of an electron in the second orbit of hydrogen atom is E2. The energy of the electron in the third orbit of helium plus. Okay, now this is a partly deleted question, but I have kept this question because similar questions without the helium part may come in your exam. So what is that question? First of all, we know that electron energy of hydrogen in any orbit is given by minus 13.6 by n square. Okay, for most cases we can ignore the negative sign, but some cases we will consider it. Okay, so second orbit of hydrogen E2 is minus 13.6 divided by 2 square, right? So minus 13.6 divided by 4. This is the energy for hydrogen atom in second orbit. Now what will be the energy for helium atom? Okay, for helium atom, okay, for any atom with the atomic number Z, okay, it is given by minus 13.6 by 4 n square. Okay, this is for atomic number Z, not mass number. Atomic number means number of protons in the nucleus. Okay, so how many protons are there in helium? There are 2 protons are there in helium. Okay, so 13.6 times 2 square, and what orbit? Third orbit. So n is 3 square, so it will be minus 4 by 9 times 13.6, right? So 4 by 9, 2 square is 4, 3 square is 9, so 4 by 9 times 13.6. Now let me rearrange it. 4 by 9 times 1 extra 4. Why I am doing that? You will know that very soon. 13.6 divided by 4. So what we have done? We have multiplied with 4 and divided by 4. Why? Because in the question E2 is given. So what is the value of E2? E2 is 13.6 divided by 4. So we have to bring this number here so that we can compare, right? So 13 minus 13.6 by 4 is E2. So what we will do? 4 4s are 16 divided by 9 times E2. Okay, so 16 by 9 times E2. So correct answer is 16 by 9 times E2, option B. Okay, now I have solved this question while doing the regular class. If you missed it, don't worry, I am solving it again. A beam of fast moving particles were directed towards the thin film of gold. The parts A, B and C of the transmitted and reflected beams corresponding to the incident parts A, B and C of the beam are shown in the adjoining diagram. The number of alpha particles in it is given by. So as I discussed during our class note that, so here they have asked you that what, so A, B and C are the incident beams, okay, and it is directly getting reflected, it is getting without a deviation, and it is getting deviated by more than 90 degrees, not more than 90 degrees, some angle, okay, some angle it is getting deviated. It is getting deviated by 180 degrees, okay, so it is getting deviated by 180 degree, right? Now for which they have asked that the number of alpha particles in which one will have the highest number of alpha particle. As we know, most number of alpha particles go without any deviation. So most number of alpha particles will be in A dash, okay, and least number 1 in 8000 goes more than 90 degree, okay, so it is actually for 180 degree deflection, it is 1 in 12,000, okay, 1 in 12,000 goes 180 degree, so it is very very less, and some 0.14% goes more than 1 degree, so this is more than 1 degree, so it will be like 1 in 3000, 1 in 4000, like that, okay. So this is also very small. So first of all, this is the largest, this is the smallest, this is in between, okay. So this is maximum, this is the minimum. Now let us read the options. A dash will be minimum, wrong. C dash will be minimum, wrong. B dash will be minimum, is correct, and C dash is maximum. C dash maximum is wrong. A dash will be maximum and B dash will be minimum. So correct answer is obviously option D, because in option D we can see that A dash will be maximum and B dash will be minimum, right? Now in this question, when it came in the year, exact year, okay, the question all the options are given were incorrect. Okay, none of the given options were correct, so it was given as a bonus mark for that year. But I have edited the question so that it makes some sense, it is correct, so that's why there is a star mark here. Okay, so this question is not exactly as per year, because as per year the questions no options was correct, so it was given as a bonus question. Okay, but I have changed it, so that's why I have added this asterisk marks. Now question number 8, the period of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to. So what is the time period? So electrons are orbiting in the hydrogen atom. Okay, they have asked to find the time period with which it is proportional to based on the atomic quantum number, right? So we know that time period is 2 pi by omega. Time period is 2 pi by omega. So time period is 2 pi by omega. Omega, again v, linear angular velocity, is r omega. So omega is v by r, right? So what is this value? Value is omega is v by r, so 1 by omega will be 2 pi r by v. Okay, now we know that this is atomic number, right? So what we will do, we will write this like this, Tn equals to Vn Rn. Okay, now what is Rn? We know that Rn is proportional to n square, and this velocity is proportional to 1 by n. If you followed our lecture, I have discussed this. So what is 2 pi? Rn is n square and Vn is 1 by n square. 2 pi is constant, so I will not write it anymore. So n square by 1 by n, so n square times n, so it is n cube. Okay, so time period is proportional to n cube. Okay, so remember that time period is proportional to n cube, and frequency, if you followed our lecture, that time I have discussed frequency is proportional to 1 by n cube. So frequency is nothing but 1 by t, right? So frequency and time period are related like this. So if frequency is f, time period is t, then frequency is 1 by t, okay, and time period is 1 by f. Okay, so in this case, if you find the time period n cube, then frequency will be 1 by n cube. Okay, we will see a similar question coming soon. Okay, now angular momentum of an electron in the hydrogen atom is 3h by 2 pi. H is Planck's constant. The kinetic energy of the electron is very interesting, but it's a question which is only to fool you. We know that angular momentum is nh by 2 pi, and here it is given by 3h by 2 pi. So from this equation we can write n is equal to 3, right? Now what is the energy? Energy is minus 13.6 divided by n square. Okay, so minus 13.6 divided by 3 square, so it is minus 13.6 divided by 9, so it will be 1.5 approximately. Okay, so 9 ones are 9, then 4.5, 4.6 means almost half of the 9, so 0.5. Okay, so this is the energy of the total energy of the electron in the third orbit. Now if total energy is this, then kinetic energy, you should know this, kinetic energy relation is equals to minus total energy. Okay, so this is the total energy, right? So kinetic energy is my negative of the total energy, that is minus of minus 1.5, so it is 1.5 eV. Okay, so 1.5 eV is the kinetic energy of the electron. Now let's move on to question number 10. In the Rutherford experiment for head-on collision of alpha particle with a gold nucleus, the impact parameter. Head-on collision means what? So this is the gold atom, okay, this is the alpha particle, and head-on collision means they are colliding directly. Now what is then you think is the impact parameter? Impact parameter is the distance between the center and the path trajectory of the alpha particle. So what is the impact parameter? Obviously their head-on collision means B should be 0, right? So impact parameter should be 0, right? Now frequency of revolution of an electron revolving in the nth orbit of hydrogen atom is proportional to. So I just told you in our previous question that this question will come very soon. So we have already deduced that T is equal to T proportional to n cube. So frequency should be proportional to 1 by n cube. Now if you want to solve it independently, then F is nothing but 2 pi by omega. Okay, so now from here we can find that omega is R by V. So V will go up, R will come down. So 2 pi times V is proportional to 1 by n square. V is proportional to 1 by n and R is proportional to n square. So it will be, because R is in denominator, so it will be n square. Multiply them, then it will get 2 pi 1 by n cube. This is proportionality equation. This is not the exact equation. So F is proportional to 1 by n cube. Okay, so correct answer is option C. A hydrogen atom in ground state absorbs 10.2 eV of energy. The orbital angular momentum of the electron is increased by. So first of all, the difference in energy is given. So delta E is 10.2. Now this is very interesting question, because you need to know when it will be 10.2, otherwise you will not be able to solve it. So either you can start, okay, in ground state the energy is minus 13.6. Okay, in ground state that is n equals to 1. So what will be the after absorbing, suppose the new energy of E star will be 10.2. So what is the new energy? New energy, this much energy is absorbed, delta E. So what is the new energy? New energy, say E star equals to 3.4 eV, right? So it is 3.4 eV. So when it will be 3.4 eV, that you have to find. So it is minus 13.6 divided by n square equals to minus 3.4. So n square equals to 13.6 divided by 3.4, negative cancels. So it will get, this will be 4. So n equals to 2. But if you know that for n equals to 2 the energy difference is 10.2, then it will be very easy for you. Okay, so now they have asked you to find the orbital angular momentum of the electron increased by. So what is the orbital angular momentum in ground state? Orbital angular momentum in ground state is L1, say h by 2 pi, right? Because h by 2 pi means nh by 2 pi, n is equals to 1. Now what is the next state? Next state is L equals to 2. So it will be 2h by 2 pi. Little bit critical, as we are not very used to solving problems like this. This is little bit difficult concepts. Okay, from web optics onwards, the concepts are little bit difficult, because we have never ever tackled this kind of concepts, this kind of questions. So this might feel a little bit awkward, but if you practice, you will be able to answer such questions. So L2 minus L1 will be 2h by 2 pi minus h by 2 pi. So that is equals to h by 2 pi. Okay, so what is h? H is 6.6 times 10 to the power of minus 34. What is 2 pi? 2 pi is 2 times 3.14. Now I already did this kind of approximation. Before that I said this you can cancel, so you will get 1. Okay, so 1 times 10 to the power of minus 34 joule second. Okay, so if you see the options, only one option is very close to our answer, that is 1.05 times 10 to the power of minus 34 joule second. So this is the answer, right? Easy. Now next question. The total energy of an electron revolving in the second orbit of hydrogen atom is. So total energy of electron revolving in the second orbit of hydrogen atom, we already know the formula. Total energy is equal to minus 13.6 divided by n square. Don't get confused about the wordings, about the terms total energy. Total energy, kinetic energy same. Only thing is kinetic energy is positive, total energy is negative. Okay, so this is the simple thing that you can remember. So second orbit, right? Second orbit means n square is n is 2. So 4. Okay, so it will be 3 4s are 12 times 3 4s are 12, in hand 16. 16 means 4 4s are 16, right? So 3.4 eV. So minus 3.4 eV is the total energy at second orbit. Okay. Now question number 14. The period of revolution of an electron in the ground state of hydrogen atom is T. The period of revolution of electron in the first excited state is. Now we already solved it. I am not going to solve it. T proportional to n cube. Okay, Tn is proportional to n cube. Now ground state is T equals to 1 and first excited state is n equals to 2. Okay, so T1 by T2. Okay, T1 by T2. Now T1 is given as T. Ground state it is given as T. And they have asked you to find the first excited state, that is T2. Okay, so it will be 1 cube divided by 2 cube. Right. So now do the cross multiplication. 2 cube is 8. So 8T equals to T2. So T2 is 8T. Simple question. Okay, if you remember, this is proportional to n cube and frequency is proportional to 1 by n cube. Such questions will be answered. So this is a very basic question, comes based on the time period, based on the frequency, which is very simple. Okay, now question number 15. The energy in EV required to excite an electron from n equals to 2 to n equals to 4 state in hydrogen atom is. Now very interesting question. So you are exciting from n equals to 2 to n equals to 4. Okay, so first of all the answer will be positive, answer won't be negative. So negative answers you can simply ignore. Okay, these are wrong answers. Okay, because you are exciting means you have to give the energy. By default the energy is negative. Now we know that the energy of N2 is minus 13.6 divided by 2 square. So minus 13.6 by 4. So that is minus 3.4. We already solved it, right? And n equals to 4. Now let us solve n equals to 4. Minus 13.6 divided by 4 square. So minus 13.6 divided by 16. Okay, so it will be minus almost 0.9. Okay, 0.8, 0.9. I am assuming it 0.9. So what is the difference then? Difference who is as you can see, this is lower energy, this is higher energy. More less negative means higher energy. So what is the difference in energy? How much energy we have to put? E4 minus E2, that is minus 0.9 minus 3.4. So it will be 3.4 minus 0.9, because negative negative positive, right? So you will get about 2.9. Okay, 2.9. So I approximated the value. So correct answer will be 2.55. Okay. Now let's move on to the next question. The scientist who is credited with the discovery of nucleus, obviously Rutherford, not Niels Bohr. Okay, not Thomson, not Balmer. It is Rutherford. Okay, you should be careful. Now the total energy of electron in an excited state of hydrogen atom is minus 3.4 electron volt. The kinetic and potential energy of the electron in this state. So you don't need to, we know this is for second state of hydrogen, right? We have solved so many problems. So by now we know that, but we are not interested in that. They have asked you to find the kinetic energy. Total energy is given minus 3.4 electron volt. So what I said, the kinetic energy will be, kinetic energy is nothing but the positive value of that. So kinetic energy is minus E total, that is 3.4 eV. So kinetic energy we have calculated. Now total potential energy. Now what is potential energy? We know that kinetic energy plus potential energy should be equals to E total, right? So potential energy should be E total minus K. So E total is minus 3.4 and K is 3.4, and again now there will be negative sign, so it will be minus 6.8 eV. Okay, so kinetic energy is 3. Kinetic energy can never be negative value. Okay, if you remember something from your P1, you should remember that kinetic energy can never be negative. So 3.4 and minus 6.8. So correct answer is option B. Okay, now question number 18. When electron jumps from n equals to 4 level to n equals to 1 level, the angular momentum of the electron changes by. Simple question. Simple question. At n is equal to 4, angular momentum is 4 h by 2 pi. At L equals to 1, angular momentum is h by 2 pi. Right? So difference is L4 minus L1 equals to 4h by 2 pi minus h by 2 pi. So difference, they have asked you to find the difference. So you have to find the difference. So 3h by 2 pi. So correct answer is option C, 3h by 2 pi. Now, which of the following spectral series of hydrogen atom is lying in the visible range? Only Balmer series is visible, other series are not visible. So we will only mention Balmer series. Now, what is the energy of the electron revolving in the third orbit expressed in eV? So electron in third orbit is, they have only given in positive values, so we are not using the negative sign. Okay, divided by 3 square, third orbit, right? So 13.6 divided by 9. So 9 ones are 9. Okay, 9 ones are 9. There is one more, so 4 and 4.6. So first of all, we have to use this decimal. So 46. 46 means 5 nines are 45. So 5 nines are 45. So it will be 1.51 electron volt. Okay, simple. Now we have reached at the end of this lecture. So if you find this lecture useful or how we can improve on it, you can mention that in the comment below. Also share it with your friends, and if you have not yet subscribed to our channel, don't forget to subscribe to our channel. I will be back with KPL on Sunday. There will be no lectures tomorrow and day after tomorrow. Okay, so that was the surprise, but I gave it to you now. So there will be no lectures tomorrow and day after tomorrow because of the Dussehra celebration. So I will be back with KPL on Sunday. Sunday there will be KPL. Don't worry about it. Okay, KPL session we are continuing. Okay, and then on Monday onwards we will start nuclei chapter. So stay tuned for it. I will be back. Thank you.